Welcome to the Explainer. So if you've ever stared at a massive petrochemical plant, or maybe a sprawling waterworks facility, and found yourself wondering, how in the world do they keep those gigantic pipes sealed so tightly? Well, you are definitely in the right place. Today, we're unpacking the ultimate guide to a massive industrial problem, large diameter piping standards. Specifically, we're going to answer the question, what is ASME B16.47 Series B, and why is it considered the lean, mean, bolt-dense specialist of the engineering world? Okay, let's dive right into this, because here's the core issue engineers are constantly facing out in the field. What actually happens when your pipes outgrow the 24-inch limit? You see, in the industrial piping world, the standard rulebook is ASME B16.5. But the committee who wrote that standard, they just stopped at 24 inches. They literally didn't design dimensions for anything bigger than that. So when your pipeline suddenly stretches out 26, 36, or even 60 inches in diameter, those standard rules completely break down. We desperately needed a heavyweight standard to step in and fill the gap.
So, here is our roadmap for this explainer. First up, beyond 24 inches. Second, the API 605 legacy. Third, Series A versus Series B. Fourth, specs, materials, and dimensions. And finally, choosing the right flange.
Let's start with Section 1. Beyond 24 inches, outgrowing ASME B16.5.
Because the B16.5 committee didn't venture past that 24-inch mark, a brand new standard was born to handle the really big stuff, and that is ASME B16.47. Think of this as the overarching rulebook governing large-diameter steel pipe flanges. Specifically, it covers weld neck and blind configurations in those massive sizes, ranging from 26 all the way up to a whopping 60 inches. Basically, if you're building giant infrastructure, this is your new Bible. Moving right along to Section 2, the API 605 legacy, two legacy standards unified.
Now, ASME B16.47 isn't just one big monolithic set of rules. It's actually an umbrella that covers two completely different, competing engineering philosophies that developed side by side for decades. Before they were brought together, we had two major players. On one side, you had the MSS SP44 legacy, which was known for these incredibly thick, heavy, high-stress designs. Under our modern standard, this became known as Series A. But our focus today is on the other side of the aisle, the API 605 standard, created by the American Petroleum Institute. This was highly prized because it prioritized lightweight construction and cost-effectiveness. Today, that API 605 legacy lives on as ASME B16.47 Series B. In fact, industry regulars often just affectionately call Series B the compact flanges.
All right, Section 3, Series A versus Series B, the showdown.
Now, what's really interesting about this is comparing the heavy lifter, Series A, with our leaner specialist, Series B. They share the same overarching standard, but they approach the exact same job entirely differently. Let's break down the physical trade-offs. Series A, it has a larger outside diameter, it's significantly heavier overall, and it uses fewer but much larger bolts. It's built to take on high external loading and massive bending moments. But Series B, it goes the other way. It has a smaller outside diameter, and it's much lighter. To compensate for being thinner, Series B fights gasket creep and flange rotation by packing way more smaller fasteners into a tighter bolt circle. It is absolutely ideal when your primary focus is internal pressure rather than external forces. Oh, and one quick aside, Series B actually doesn't cover ring-type joint or RTJ faces. Now, if you're thinking you can just kind of mix and match these out on a job site, listen to this quote from Texas Flange. Series A and Series B flanges are not interchangeable. Mating one to the other in a bolted joint is not going to work without modifications. I really can't emphasize the stakes here enough. Selecting the wrong series is a ridiculously costly mistake. You simply cannot bolt a Series A flange to a Series B flange. The bolt patterns and outside diameters completely clash. You literally have to commit to one path from the start.
Which brings us to Section 4, Specs, Materials, and Dimensions, Unpacking Series B.
Since we're diving into the hard data now, let's talk about the number 75. This represents Class 75, and it's a pressure class that's entirely unique to Series B. It straight up doesn't exist in the Series A standard. This makes Series B an absolute superstar for low-pressure vacuum applications, or really any situation where stripping away the weight of an assembly is your primary driving concern.
And this brilliantly illustrates the concept. If we look at the precise engineering measurements for a Class 75 Series B flange, specifically paying attention to the minimum thickness, which is usually marked TF on the drawings, you can see just how shockingly lean this profile is compared to your standard heavy-duty flanges. It is a true masterclass in stripping away unnecessary bulk while still maintaining total structural integrity for its designated pressure class.
But moving up the pressure scale a bit to Class 150, we see the geometry for both weld neck and blind flanges gets a bit beefier. Now, while Series B is famous for being the lighter option, don't let that fool you into thinking it's weak. Not at all. It comfortably handles standard, highly demanding industrial pipeline pressures, scaling all the way up through Class 300, 400, 600, and yes, even 900. It's just engineered to do all of that with a much more compact footprint.
So what are these massive pieces of hardware actually made of? Well, the material flexibility of Series B is pretty staggering. You've got standard carbon steels for your everyday pipelines. You've got stainless steels for heavy corrosion resistance. There are alloy steels for extreme high temperature demands, duplex and super duplex for highly aggressive environments, nickel alloys for offshore chemical use, and even low temp steels if you're dealing with cryogenic services. Depending on the exact alloy you go with, a Series B flange can handle temperature swings from a freezing -20 degrees Fahrenheit all the way up to over 1,000 degrees. Of course, these flanges aren't usually just installed as bare metal. To actually survive in brutal chemical plants or harsh, salty outdoor environments, they need some serious surface treatments. We're talking zinc plating, passivation to boost the stainless steel's corrosion resistance, PTFE non-stick coatings for aggressive chemical runoff, and black oxide. These coatings are absolutely vital to maximize anti-corrosion and ensure those long-term sealing capabilities. And a quick reminder for the engineers watching. ASME B16.47 strictly covers only two configurations: weld neck flanges, which provide those robust, leak-proof butt weld connections for high-pressure joining, and blind flanges, which are bolted on to close off the piping and allow for easy removal during maintenance. If your project suddenly requires a large diameter slip-on flange, well, you are technically stepping completely outside the specific code.
Let's wrap things up with Section 5, choosing the right flange, making the engineering call.
So, the crucial point is how you actually apply all this theory to your next multi-million-dollar procurement decision. Step 1. Check the project spec. This is always the golden rule. If the spec says Series B, you buy Series B. Step 2. Evaluate those external loads. Are there massive bending moments at play? Because if so, you might actually need Series A instead. Step 3. Consider system continuity. Are you retrofitting an old pipeline that was originally built to API 605? If so, you absolutely need Series B to match it. And finally, Step 4. Assess your weight and cost constraints. If you are highly weight sensitive and primarily focused on internal pressure, Series B is going to be your best friend.
Which leaves us with one final thought. For your next massive pipeline project, will you need the heavy lifter or the bolt dent specialist? It's a million-dollar question, literally. Fully understanding what ASME B16.47 Series B brings to the table gives you the power to perfectly optimize your next large diameter piping project for weight, cost, and efficiency. Thanks for joining me on this explainer, and keep building big.